Hello guys, in this video we will talk about two methods for hyperparameters tuning, grid search and random search. But first, let's find out what are hyperparameters. Hyperparameters are model-specific properties that are fixed even before the model is trained or tested on the data. For example, in the case of a random forest, hyperparameters include the number of decision trees in the forest. For a neural network, there is the learning rate, the number of hidden layers, and several other parameters. Hyperparameter tuning is nothing but searching for the right set of hyperparameters to achieve high precision and accuracy. Optimizing hyperparameters considers one of the trickiest parts in building the machine learning model. There are several parameter tuning techniques, but in this lecture, we will focus on two of the most widely used parameter optimizing techniques, grid search and random search. Let's start with grid search. Grid search is a technique which tends to find the right set of hyperparameters for a particular model. In this tuning technique, we simply build a model for every combination of various hyperparameters and evaluate each model. The model which gives the highest accuracy wins. One of the drawbacks of grid search is that when it comes to dimensionality, it suffers when evaluating the number of hyperparameters grows. However, there is no guarantee that the search will produce the perfect solution, as it usually finds one by aliasing around the right set. Now let's load our digit dataset. In this example, we have SVC classifier, and we want to find the best hyperparameters for our model. So what we will do is to set the hyperparameters values that we want to search over. For example, we set the C hyperparameters values that we're interested in to 0.01, 0.1, 1, 10, and 100, and the gamma values to 0.005, 0.01, 0.05, 0.1, 1, 10, and 100. After that, we pass our SVC classifier and those values to grid search. We set a cross-validation of 5 folds and set the scoring to F1. So the set of hyperparameters that gives us the highest F1 score will be selected. Now we see that we got F1 score of 97%, and the hyperparameters that the grid search selected out of the one we told it to search over are gamma of 0.005 and C of 10. We can also see all the hyperparameters that the grid search selected to have the best score. Now let's talk about random search. Random search is a technique where random combinations of the hyperparameters are used to find the best solution for the model. It's similar to grid search, and yet it has proven to yield better results. The drawback of random search is that it yields high variance during computation, since the selection of parameters is completely random, and since no intelligence is used to sample these combinations. Just like we did with grid search, we have a classifier, this time it's KNN, and we set the hyperparameters values that we want to search over. Now we will pass our model and the hyperparameters values, cross-validation, and we set our scoring to F1 score to the randomized search. The only difference is we have to specify the number of iterations that the random search will do. Now let's run the code. Now we see that we got F1 score of 99%, and the hyperparameters that the random search selected are weights to uniform, number of neighbors to 6, algorithm to KD tree, P to 1, and leaf size to 6. We can see also all the hyperparameters that the random search selected to have the best score. Now let's compare between grid search and random search. Let's say that we have 3 by 3 set of parameters. There are 9 set parameters in each search technique. Random search works best for lower dimensional data, since the time taken to find the right set is less with less number of iterations. But in grid search, the optimal parameter is not found, since we don't have it in our grid, and that's why time is spent to find the near-best solution. The best strategy for your problem is the one that finds the best value the fastest, and with the fewest function evaluations, it may vary from problem to problem. While less common in machine learning practice than grid search, random search has been shown to find equal or better values than grid search within fewer function evaluations for certain types of problems. And by this, we end this section of effective machine learning. I hope you enjoyed it and see you soon.